Well, hello again guys, and welcome to the channel. In this video we're going to be revisiting my lovely Pentium II reverse sleeper build, because I have a few modifications and upgrades to apply, and they should finish off this build rather nicely. Before we get into the modifications and upgrades, I'm just going to perform a little test run of Doom. This machine currently has a Creative Labs CT2770 Sound Blaster 16 value installed, which was a popular sound card released in the early 1990s, and was known for its compatibility with a wide range of software and games, as well as its relatively affordable price compared to other sound cards of the time. And this is the Doom music being played from the Sound Blaster 16's MIDI synthesizer interface, and to a lot of people including myself, the sound from the SB16's MIDI synthesizer interface is a truly iconic and nostalgic sound. Brilliant! All appears to be working perfectly, and so I can now progress onto applying the modifications and upgrades. Firstly, that lovely SB16 value we have just been listening to is going to be removed because, unfortunately, the PCB just does not match the gold theme that I'm going with on this build. It has taken some time to source the card that I'm replacing the SB16 value with, but eventually I did manage to find one for a reasonable price, which I'm genuinely excited to use. And this, my friends, is the Creative Labs Sound Blaster AWE64 Gold, an absolutely beautiful card. I have rather fond memories of the AWE64 Gold, although I did not own one myself personally. An old friend of mine owned one back when we were both young teenagers, and we had a lot of fun creating our own MIDI files and using software probably proprietary to the AWE64 Gold that allowed us to use a small WAV file rather than using the onboard MIDI wavetable. The AWE64 Gold has greater polyphony support than the AWE32. Unfortunately, these additional voices are achieved via software-based processing on the system CPU. The technology called waveguide synthesizes the instrument sounds rather than using stored instrument patches like the hardware voices. This not only demands more processing power from the host system, but is not of equal quality to available sound fonts. The inability to adjust synthesis parameters, unlike with the hardware portion of the AWE64 Gold, also limited the waveguide function's usefulness. Another improvement comes from better onboard circuitry that increased the signal to noise ratio, the overall signal quality compared to the frequently quite noisy AWE32 and Sound Blaster 16 boards. This improvement is most notable with the AWE64 Gold because of its superior gold-plated RCA connector outputs. Additional improvements also come from increased integration of components on the AW64 Gold compared to its predecessor. Increased integration means the board can be simpler and tracing routes to components is reduced, decreasing the amount of noise-inducing signal travel. This also made it possible to reduce the size of the AW64's board notably compared to the AW32. The next modification is but a minor one, but I'm hoping that it will be rather effective. Just 2 single LED strips to bathe the components in a lovely orange glow. Oh yeah, they're pretty, aren't they? Should one go under here? Now I just need to decide where it's best to position these strips, and I think I've decided on where one of them is going to be located. Okay, so with the AW64 Gold now installed, that is the main upgrade to the system. As well as the AW64 Gold being a great improvement over the Sound Blaster 16 value, it also matches all of our other gold PCBs in the system. I'm just faffing here with the last LED strip, and yep, I think I'm going to place the last strip right here. And here are the results in a little photo montage. I am beginning to really like the purple and orange. For the final modification that we're going to be making, I have managed to source some lovely gold heat spreaders for the memory modules. We really don't need these heat spreaders on this speed of memory, but it will just make them look nice, and it will match the rest of the gold theme that I've been going with on this build. I will be swapping out the single-sided 256MB Micron SD RAM module for a dual-sided 128MB Hyundai SD RAM module. This board does not support 256MB memory modules, unfortunately. Lovely, this build is now complete, and I think it looks fantastic, and rather quite deceiving. Before we can move on to doing some benchmarks on this lovely system, I need to flash the BIOS to the latest version. First, we need to boot into DOS and run the Award BIOS Flash utility, and I'll be using version 8.99. In the first box here, file name to program, we are typing the file name of the new ROM file that we're going to be flashing over the old ROM. And we will make a backup of the old BIOS ROM just in case we run into any problems. And here we go, we have hold up, I've not seen this message before. Flash ROM is write protected. Please make sure whether lockout jumper is set to correct or not. Okay. After doing a little bit of investigating, I could not find any lockout jumpers on this motherboard for the flash ROM. The 8-bit ABBX6 motherboard has very little jumpers, so I then turned to Google to do a little search on my specific problem. I had read that other people had been having the same problem, and the fix is quite simple: to use an older version of the Award BIOS Flash utility. In flash attempt number 2, from our newfound information, the version of the Award BIOS Flash utility in this attempt is version 8.23, and let's hope that the internet is correct. Flashing a BIOS, or basic input-output system, can carry certain risks, primarily because it involves updating firmware that is integral to your computer's functioning. And bingo, we are flashing our BIOS. What is known as breaking your device is when something goes wrong during the flashing process, such as a power outage or interruption. It could render your device unusable, effectively turning it into a brick. This is rare, but it is still possible. Now that the flashing is complete, we can now reboot and go into the BIOS and select the correct CPU speed from the CPU soft menu. When the system is booted into Windows, we can have a look in the device manager at our newly installed hardware. Everything's looking good, so now let's just check that the AW64 Gold is working by giving it something to do. How about some Beethoven from the Windows Media folder to get us started? And how nice does that piano sound? As I mentioned earlier in this video, I spent a lot of my youth messing about making MIDI files, because that's just what you did back then. And I still have most of them MIDI files that my mate and I were both working on at that time. So it is a little bit strange to be able to install Noteworthy Composer and load up them same files 20 plus years on. For me, a truly bizarre moment. I mean, I can load these files up anyway at any time, but being able to use the original creative wavetable is quite a nice option to have available. Not only can the AW64 Gold use its fancy wavetable, it can also sound like the Sound Blaster 16 value by changing the MIDI output channel. I'll just give you a little example of some of the things that we used to create. Moving on now from my nostalgia, and Doom is what I was testing at the beginning of this video, so let's have a listen, and instantly you can notice the difference to the music. That was an absolute pleasure. I am so excited that this card is working, because the only reason I was able to find one at a reasonable price is because it had been sold as an untested junk item. Moving away from how good the system sounds and onto much more important video performance of the system by seeing how it copes with a time demo in the classic first-person shooter, Quake III Arena. Quake III Arena was released in December 1999 and developed by ID Software. In the 640x480 time demo, we get a score of 58.4 frames per second, which I think is a pretty decent result. Let's knock it up a gear now by changing the resolution to 1024x768 and see how she gets on. Anything above 30 frames per second is what we would like to see. The result for the time demo in 1024x768 is 35.8 frames per second, which is a pretty damn good result for a 26-year-old rig. And onto the final series of benchmarks in 3D Mark 99, and I will just let the results do the talking. The final results for the 3D Mark 99 benchmark is 2,473 3D marks and 3,876 CPU 3D marks. And those results are based on a 400MHz Intel Pentium II CPU, 128MB of SD RAM, and an Asus GeForce 2 MX200 32MB AGP graphics card. And at the moment those results seem completely irrelevant until I build a system to compare these results to. But not to worry, I'm sure that day will come. I am always building and tinkering with something, so stick around. It has been an enjoyable project and it has turned out better than I'd imagined. And it is also such a lovely machine visually and practically. I'm sure I'll have hours of nostalgic joy using this machine. Thank you for watching this final segment to my Pentium II reverse sleeper build. I will see you again soon. Enjoy the remainder of your bank holiday weekend. Take care folks.